Good evening to all my dear students. So today in this video we will study the first chapter, that is chemical reactions and equation. I have already made videos for Bengali medium student and this is for English medium student. So remember that this chapter is very important. This is the first chapter and also very much important for all of us. And especially for those who are intending to study science in future, for you this video is or this chapter is very important. So watch this video and I will try my level best to explain each and every topic of this chapter in the simplest possible way. So watch this video. So in this chapter we will have to learn the following topics. That is, first we will have to study what is chemical reaction, and then what is chemical equation, and then types of chemical equations, and then how to balance a chemical equation. And after that we will study corrosion, and lastly rancidity. So these are the topics that we have to learn in this video. Okay, let's start from the first one. What is chemical reaction? So what is chemical reaction? Chemical reaction is nothing but the change of chemical substance, change of one type of chemical substance into another. For example, CaCO3, this is calcium carbonate. If we heat this calcium carbonate, it will form calcium oxide and carbon dioxide. So in this case, what happens, you see, one type of chemical substance changing into another type of chemical substance. This is called a chemical reaction. Another case, for example, if carbon, that is coal, react with oxygen, it will form carbon dioxide. This is also a type of chemical reaction. So what happens, you see, in chemical reaction, one set of chemical substance transform to form another set of chemical substances, and the chemical substances that are formed after changing, their physical and chemical properties are entirely different from the physical and chemical properties of the substance from which it is formed. And the substance which changes to form the product are called reactant, and the substance which is formed after the changing is called product. So the definition stands as the process in which one set of chemical substance transform into another set of chemical substance. This is called chemical reaction. Now one question arises that how these chemical reactions occurs. These chemical reactions occurs either by means of bond breaking or by means of bond formation. In first case, what happens, you see, here only one reactant, calcium carbonate, breaks down to form calcium oxide and carbon dioxide from one substance, forming two other substances. So here what happened, obviously here a type of bond breaking takes place, and that's why calcium oxide and carbon dioxide is formed. So this chemical reaction is carried out by means of bond breaking. But in this case, what happens, you see, here carbon and oxygen, two chemical substances, reacts together and form carbon dioxide. So in this case, what happens, you see, that carbon reacts with oxygen and form carbon dioxide, and here a type of bond formation takes place. So the chemical reactions occurs either by means of bond formation or by means of bond breaking. Here the two examples. In this example, bond breaking occurs, and in this case what happened, bond formation, bond making or bond formation. So chemical reaction is the process in which one set of chemical substances transform into another set of chemical substances either by means of bond breaking or by means of bond formation. This is chemical reaction. And one important thing, that the product that is formed, their physical and chemical properties are entirely different from the physical and chemical properties of the reactant from which it is formed. Chemical properties of this substance is quite different from the chemical properties of these two substances. Let us see another example. This is quite simple to understand how properties change. For example, when hydrogen H2 reacts with oxygen O2, it forms H2O, that is water. So what happens is, see here, the hydrogen is a highly inflammable gas. Whenever it comes in contact with flame, it burns up. And oxygen is a type of gas which helps in burning. So here one is a highly inflammable gas, burns up in contact with flame, and another one is the type of gas which helps in burning. And these two gases combines together and forms water. Now you know the property of water in case of flame. Water extinguishes flame. So here obviously the product which is formed, whose physical and chemical properties are entirely different from the reactant. Apart from this, we can also say that the physical property, there is the physical state in hydrogen. Hydrogen is found in gaseous state, gaseous form at room temperature. Oxygen is also found in gaseous form at room temperature. But water you will find in liquid form at room temperature. So from all this discussion, we can conclude that chemical reaction is the process in which one set of chemical substance transform into another set of chemical substance either by means of bond breaking or by means of bond formation. And the product formed in this process, whose physical and chemical properties are entirely different from the reactant. So if anyone asks us what are reactant, how will you define reactant? Reactant are the chemical substances. These are the reactant. Reactant are the chemical substances which change to form the product. Where the change takes place. These are the reactant. And the product are the chemical substances which is formed after the change. Okay? So this is all about the chemical reaction. And there are different types of chemical reactions are there, and we will discuss the types of chemical reactions after discussing the chemical equation. Chemical equation. So after chemical reaction, what is chemical equation? So chemical equation is nothing but the representation. Chemical equation is nothing but the representation of chemical reaction. The way we will represent a chemical reaction is the chemical equation. For example, from the earlier equation, we can use the earlier equation as an example. When hydrogen, if we say that a chemical reaction, like when hydrogen reacts with oxygen, it forms water. So this is a chemical reaction. When hydrogen reacts with oxygen, it forms water. This is a chemical reaction. And if we state this chemical reaction by using sentences, we will have to explain like this. When hydrogen reacts with oxygen, it forms water. It forms water. So this is a sentence statement. This is a sentence form. By using a sentence, we are saying that hydrogen reacts with oxygen to form water. So this is quite long. this is a quite long process. By using a sentence to express a chemical to express a chemical reaction by using a sentence is quite long. This is a sentence. Here so many words are there. When hydrogen react with oxygen, it forms water. 1, 2, 3, 4, 5, 6, 7, 8. 8 words are there to express a chemical reaction. So this is quite long. So if we use the word simply, it will stand like this: hydrogen plus oxygen produces water. This states that when hydrogen reacts with oxygen, this plus sign indicates that when hydrogen reacts with oxygen, it forms water. This is a type of chemical equation. It's a word chemical equation. By using words, we are expressing a chemical reaction by using words. So this is a word chemical equation. So this is quite simple compared to this one. This is a sentence statement. With the help of a sentence, we are stating or we are explaining a chemical reactions. Here 8 words are there. But this is a word equation. Here only 1, 2, 3. Only 3 words. This word equation can also be written in the more concise form, in a more simple way, simply by using the chemical formula of hydrogen and oxygen. This will be more simple and concise. So it will stand like this: hydrogen. In place of hydrogen, we will simply write the chemical formula of hydrogen, and in place of oxygen, we will simply write the chemical formula of oxygen. So chemical formula of hydrogen is H2, and chemical formula of oxygen gas is O2. It combines to form water. The chemical formula of water is H2O. So this is more concise and simple compared to this one, and this is more simple compared to this one. So the process by which we represent or we explain a chemical reaction is the chemical equation. So how will you define a chemical equation? A chemical equation is the process of representation of a chemical reaction by using some formulas and symbols. Okay, so this is the chemical equation, definition of a chemical equation. So this is the definition. Definition of chemical equation is the process of representation of a chemical reaction by using chemical formula and symbols are termed as chemical equation. For example, you can write the example by using the sentence. For example, it will be quite long if we write all these things here. You can simply write that to represent a chemical reaction between hydrogen and oxygen, we will have to if we use sentence, we have to write that when hydrogen reacts with oxygen, it forms water. So instead of using sentence, we can represent this reaction simply by using words, and it will stand like that: hydrogen plus oxygen produces water. And in more concise way, we can represent this equation also by using formula of hydrogen and formula of oxygen and formula of water. So this is all about the chemical equation. One thing I forgot to give you the definition of chemical reaction. 1 minute. So this is the definition of chemical reaction. It is a process in which one set of chemical substance transformed into another set of chemical substances are called chemical reaction. The chemical and physical properties of the new substances formed are entirely different from the chemical and physical properties of the reactant. You just write it just before the chemical equation. Okay. So again coming to the chemical equation. In some cases you will find that the number of atoms in the reactant is not similar, is not equal to the number of atoms in the product side. That is, for example, H2 plus O2 produces H2O. In this equation, what happens is, see here, 2 hydrogen atoms and 2 oxygen atom combines to form water molecules, but in water molecule only 1 oxygen is there. That means 1 hydrogen is disappeared from this process, right? But in our previous classes, that is in class 8 and 10 probably, we come to know from the Dalton's atomic Dalton's postulates that mass can neither be created nor destroyed in chemical reactions, or atoms can neither be created nor destroyed in a chemical reaction. That means no atom will form in a chemical reaction, or no atom will destroy by means of a chemical reaction. But here one oxygen atom is disappeared. That means one oxygen atom is vanished here. But this is practically not possible. According to Dalton's postulate, this is not possible. So this type of chemical equations where only the chemical formula is mentioned, but there is no physical state is mentioned, and the number of atoms in reactant side and the product side is not equal. If number of atoms and the number of atoms is not equal in both the sides, then obviously the molecular mass will also not be not equal in reactant and the product side. And this is practically not possible. According to Dalton's postulates, this is not possible. So this type of chemical equations where the chemical equation is unbalanced and no physical state is mentioned, this type of chemical equations are called skeletal chemical equation. So what is skeletal chemical equation? Skeletal chemical equation. So skeletal chemical equations are the chemical equations in which only the formula of the reactant and the product is mentioned. No physical state and other informations are provided in this reaction. This type of equations are called skeletal chemical equation. Okay, and this type of skeletal equation, we need to balance this type of skeletal equation. And if we balance this one, it will stand like this. And the chemical equations whose the number of atoms in the reactant side and the number of atoms in the product sides are equal. That is, the mass of the reactant and the mass of the product are equal. This type of chemical equations are called balanced chemical equation. But now the question arises that why a chemical equation need to be balanced, balance. This is important because we know that from Dalton's postulates, we know that mass can neither be created nor destroyed in a chemical reaction. So it is necessary to balance a chemical equation. This is the answer, that why a chemical reaction necessary to balance, right? So this is all about the chemical equations. Now coming to the next point, that is the types of chemical reaction. Third point is types of chemical equation. Basically, we have 5 different types of chemical reactions. Sorry, chemical equation, not it's chemical reaction. Basically, we have 5 different types of chemical reactions, in which first one is combination reaction, and then decomposition reaction, and then displacement reaction, and then double displacement reaction, and the last one is oxidation reduction reaction, that is redox reaction. So a combination reaction, decomposition reaction, displacement reaction, double displacement reaction, oxidation reduction reaction, also called redox reaction. So these are the 5 fundamental types of chemical reaction. This is combination reaction, decomposition reaction, displacement reaction, double displacement reaction, oxidation reduction reaction. So in simple way, if we explain that combination reaction, the structure of combination reaction will be like this: A plus B produces AB. That means when two reactant combine together, this is reactant. The chemical substance which changes, that is the substance which are in the left hand side of the arrow. This is called reactant. We know it. When two or more reactant combines together to form a single product, this is called combination reaction. Always you will find combination reaction in this form, and the decomposition reaction will be in this form, opposite to this one, in this form. Displacement reaction, in this form. You will find displacement reaction in this form. Double displacement reaction, like this way. Oxidation reduction reaction, oxidation reduction is different. Here we can explain oxidation and reduction in terms of oxygen. In one case in terms of oxygen, and another case in terms of hydrogen. So in case of oxygen, okay, we will explain it later. First explain this 4 chemical reaction. So first one is combination reaction. How will you define the combination reaction? Combination reaction is the type of reaction in which two or more reactant combines together to form a single product. Two or more. It may be like this: A plus B plus C, ABC, or AB plus C. Simply, when two or more reactant combines together to form one single product, this type of chemical reactions are called combination reaction. So if we define it, when two or more reactants combines together to form one single product. This type of chemical reactions are termed as combination reaction. It will be in this form: A plus B produces AB. For example, H2 plus O2. Always use the simple chemical reaction which you can memorize. H2 plus O2 produces H2O. C plus O2 produces CO2. Mg plus O2 produces MgO. All these are the example of combination reaction. So combination reactions are the chemical reaction in which two or more reactant combines together to form one single product. To form one single product. This type of chemical reactions are called combination reaction. Okay. Now coming to the next, that is decomposition reaction. Decomposition reaction is actually the opposite of combination reaction. Decomposition reaction. Decomposition reaction is the opposite of combination reaction. Here, one single reactant decompose to form two or more product. The chemical reactions in which one single reactant decompose to form two or more product. Two or more product. Are termed as decomposition reaction. It will be in this form: A plus B. AB decompose to form A plus B. 2. For example, CaCO3 decompose to form calcium oxide plus CO2, carbon dioxide. Another example, PbNO3 twice decompose to form PbO plus NO2 plus O2. All these are the example of decomposition reactions. H2O. The reverse is also possible. H2 plus O2. Electricity. If we pass electricity through water, it will decompose to form hydrogen and oxygen. So this type of chemical reactions in which one single reactant decompose to form two or more product, this type of chemical reactions are called decomposition reaction. For example, these are the example. You took the screenshot. And then the third one is displacement reaction. Displacement reaction. Displacement reaction is the reaction in which one element or one atom displaces another atom from its compound. One atom, for example, A plus Bx. Here A will replace this B and will form Ax plus B. A replaces B from its compound. This Bx is the compound of B, and A replaces this B from its compound and forms Ax. This is the new chemical substance. Displaces B. This type of chemical reactions are called displacement reaction. One condition is there. In displacement reaction, A should be the atom which replaces another atom from its compound. It must be more reactive. It must be more reactive. In reactivity series, it must be in the upper side. Only more reactive atoms can replace a less reactive element or atom from its compound. So the definition will stands like the chemical reaction in which a more reactive element displaces another atom from its compound to form new chemical substances, that is the product. This type of reactions are called displacement reaction. Example of displacement reaction: when Fe is more reactive than copper. So when Fe reacts with copper sulfate, it will displace copper from the copper sulfate solution, copper sulfate compound, and will form ferrous sulfate and metallic, that is solid copper, will displace from here. So this type of reactions are called displacement reaction. Displacement reactions are the chemical reactions in which a more reactive atom displaces another atom from its compound to form new chemical substances, that is product. This type of chemical reactions are called displacement reaction. Here the condition is that the atom which will displace another atom from its compound must be more reactive than this one. Okay, this is all about the displacement reaction. And the next one is double displacement reaction. So double displacement reactions are the reactions in which double displacement reaction are the reactions in which the position of ions are exchanged together. So double displacement reaction: AB plus XY. Suppose this is positive, this is negative, this is positive, this is negative. So exchange of ions takes place. What is ion? I hope you all know that what is ions. Bx. Exchange of ions. Simply the exchange of ions takes place. Here A is as a positive ion, and in this compound it combines with B as a negative ion, and here X is a positive ion and Y is a negative ion. Simply the exchange of ion takes place. Here positive A combines with Y and positive X combined with B. This type of chemical reactions are called double displacement reaction. The chemical reactions in which exchange of ions takes place between the reactant compounds. Its structure will be like this: A b plus xy, positive negative, then it will be ay plus bx. For example, Na2SO4 plus BaCl2. Sodium sulfate, when reacts with barium chloride, it forms NaCl plus BaSO4, barium sulfate. And this barium sulfate will appear as precipitate. That is, this will not dissolve. It will be found in solid form. So this is called double displacement. The chemical reactions in which exchange of ions takes place between reactant compounds are termed as double displacement reaction. Okay, you take the screenshot. Now moving to the next one, that is the last one, the oxidation and reduction reaction. Oxidation and reduction. So we will explain oxidation and then reduction. First of all, in terms of oxygen, if we define oxidation in terms of oxygen, it will stand like this. Oxidation is nothing but the addition of oxygen is called oxidation. That is, here addition of oxygen occur. This type of reactions are called oxidation reaction. Reduction. In terms of oxygen, if we define reduction, this is the loss of oxygen is called reduction. In terms of oxygen, here oxygen is separated, is out from the compound. So this type of reactions are called reduction reaction. Now, if we define in terms of hydrogen, that is, in terms of hydrogen, this is quite opposite to this. In terms of oxygen, the addition of oxygen is called oxidation, but in terms of hydrogen, this is opposite. The loss of hydrogen is called oxidation, and reduction, gain or addition, of hydrogen is called reduction. So in terms of oxygen, the definition of oxidation stands as the addition of oxygen is called oxidation, and reduction, the loss of oxygen is called reduction. And in terms of hydrogen, it stands as addition of oxidation, loss of hydrogen is called oxidation, and gain of hydrogen is called reduction. And if we combine the oxygen and hydrogen together, and if we want to explain the definition of oxidation and reduction in combined form, we can say that the addition of oxygen or the removal of hydrogen is called oxidation, and on the other hand, removal of oxygen and or addition of hydrogen is called reduction. So this you can write. I'm not going to write this as it will take much time. I can repeat it again. Oxidation in terms of hydrogen and oxygen will stand as the addition of oxygen or the removal of hydrogen is called oxidation, and on the other hand, the removal of oxygen or addition of hydrogen is called reduction. And now what is oxidation reduction reaction or redox reaction? If the term is given as oxidation with a small hyphen, that is, if you found that oxidation reduction, if it is like this, oxidation reduction, this is called redox reaction. Redox reaction. These are the reaction when in a single chemical reaction, one reactant oxidized and the same time another reactant reduced. So this type of chemical reactions are called oxidation reduction or redox reaction. For example, CuO plus H2. For example, if cuprous oxide CuO reacts with hydrogen, it will form copper and H2O, that is water. Here this reactant losing oxygen and form copper. So here the process is loss of oxygen is called reduction. And what happens, you see, in hydrogen gaining oxygen, hydrogen is gaining oxygen to form water. So this is oxidation. So in a single chemical reaction, one reactant is oxidizing and another one is reducing, and this type of chemical reactions are called oxidation reduction or redox reaction. In oxidation reduction reaction, here you will get a hyphen. So this is all about the first chapter, and the next video we will discuss how to balance the chemical equation and then corrosion and rancidity. So this video is over here. This video is complete here, and I hope you have learned on all the things that I have discussed. Okay, we can summarize once again what we have learned or what we have studied in this video. The first one is what is chemical reactions, and then types of chemical reactions, what are chemical equations, and two types of chemical equations, that is skeletal chemical equation and balanced chemical equation, and why it is necessary to balance the chemical equation. And then we learn about the different types of chemical reactions, that is combination reaction, decomposition reaction, displacement reaction, double displacement reaction, and then oxidation reduction reaction. Okay, so thanks to all of you for watching this video, and wait for the next video. In next video I will discuss how to balance a chemical reaction, chemical equation, how to balance a chemical equation, and then I will discuss the rancidity and then corrosion. Okay, thanks.